Welcome to SanfordFlipMath. We are working on AP Calculus, steadily working through the Finney, Demana, Kennedy book, currently in Chapter 6, which is all of the differential equation stuff. This particular video is meant to kind of pull together sections 6.1 through 3. 6.1 was basically focusing on anti-differentiation, basically just undoing the rules of taking derivatives. Section 2 focused specifically on when we have what's basically the results of doing the chain rule, where you have a function inside of a function, and then you end up with the derivative of that inside function sitting there as part of the integrand, what you're taking the integral of, and how to reverse that using U substitution. Section 3 then focuses on what was the result of the product rule. And so basically you have a product sitting there, but it's not from the chain rule, and so you have to go through a hoopla and follow kind of a whole separate format, which is basically a rearrangement of the product rule that has been anti-differentiated, word for the day. Okay, so the question is, what do you do when? Well, basically you need to recognize what has happened. So if you have something that's just been a straight up normal derivative, antiderivative, undo it. If it's connected to, you might have separate terms connected by addition or subtraction, and again, remember you can anti-differentiate term by term. So if you have any kind of terms separated by addition or subtraction, just follow the derivative patterns and do the antiderivative. Okay? Now, again, this is connected by addition or subtraction. That's the big deal here. Or if you can rearrange things using some algebra, so that's the case. This is the simplest, easiest method to use. Okay. Sometimes, as has been stated, if you have a function inside of a function and you have some form of that inside function's derivative connected by multiplication, then you're going to do U substitution. And again, you set up U is equal to whatever the inside function was. You have to do the derivative of that and then do some substituting, and then you can go from there. And then ultimately, if you have a product, again, that is not from the chain rule, okay, so it's not like a function inside of a function. Now, you could be using a combination of things, but typically, when you're talking about some kind of a product that is not from the chain rule, then that's where doing antiderivative by parts comes through. Okay, so the focus here is kind of eyeballing examples and how do you do what, when do you do what, etc. Okay, so these two problems look very, very, very similar, and their processes for doing antiderivative they're completely different. So things to notice here. Okay, first of all, I have division going on. Well, that's nice. I can't separate like this. This is not how the rules for fractions work. I cannot take apart this thing into two separate fractions, at least not like that. There will be a method toward the end of Chapter 6 called partial fractions, which sometimes works, and it wouldn't work very comfortably on this one, although you could force it, I suppose. Okay, so what we're going to do then is look for other ways. Okay, so if I look at this denominator as a chunk, as a complete separate entity, think of this as 1 over something, and then this is that something. Okay, and then there's this 3x being multiplied. This x squared minus 3, I'm going to go ahead and just call it u because that's what I'm going to end up doing. And then notice this part is a form of the derivative. It's really not the derivative because the derivative of this inside would be 2x. This is 3x, but again, when we have a multiplication by a constant or division by a constant, we can pull that out in front and it's a non-issue. Okay, so I'm seeing x, and the derivative of u, du dx, is 2x. So I'm going to be able to do parts on this. Okay. All right, so, or I'm sorry, not parts, U substitution. I misspoke. Okay, so let's just go ahead and carry that out. So again, the process is I'm going to need to replace the dx with something, so I'm going to go ahead and solve for that. So dx, I don't really need the underlining there, sorry. Dx equals du over 2x. Okay, so I'm going to rewrite this. And so I still have 3x over, I'm going to call this u. And in place of dx, I'm going to write du over 2x. And then I have some stuff that's going to divide out. The x's go away. And I have this 3 over 2 now, so I'm going to bring that out in front. And this is 1 over u du, which you can write du over u if you prefer. Okay, so all of this ends up being 3/2 natural log of u plus c, excuse me, and we'll do one more thing, and since I don't have limits of integration, since this is an indefinite integral, or just straight up antiderivative, I'm going to go ahead and replace the u back with whatever the u was. Okay. Oh, sorry, I have an equal sign in there. I know somebody was screaming at me. I could hear you all the way through time. Thank you. Mr. Sanford, you wrote an equal sign. No, I hate that being human thing. All right, that's it for this. Okay. All right, now keep in mind that it could have been an initial value problem where I'd give you an initial value, an ordered pair, and you'd have to go back and solve for c. That can happen, and you know, all that kind of stuff. All right, so my claim before was this other problem is completely different. Well, I mean, yeah, I could make x squared minus 3 into u, but du and du would be 2x, but the problem is this isn't x. This isn't times x. This is divided by x. This is really like 1/3 x to the negative 1. So this is not a u substitution problem at all. This problem, and you're going to be mad, can be split up into two separate fractions. So this just becomes x squared over 3x minus 3 over 3x. I'm going to rewrite that also as the antiderivative of, or integral of, 1/3 x minus 1 over x. And just one more time, oh no, I'm ready to do antiderivative here. So I'm going to go term by term. Now, again, this is one of those steps that I never write, but even though this is how I'm going to think about it. Okay, so I'm going to actually do antiderivative of this term separately. Okay, again, that idea is if I have addition or subtraction, then I can follow the derivative patterns to undo derivative, antiderivative, and again, I can go term by term. So in effect, I'm going to take that 1/3 out in front. This becomes x squared over 2 times 1/3 minus, now I know there needs to be a plus c there, but I'm not going to sweat that right now. This x is on the bottom, so this is really natural log of x, and again, we do absolute value for that when we're doing antiderivatives. And this is really done. I'm going to rewrite this 1/6 x squared minus ln. Okay, and that's it for that. Okay, so again, we had a way to separate that into just addition or subtraction of separate things that we knew how to do antiderivatives of. The other one had a function inside of a function, and I know it's not easy to see this, and the more you get practice, the more you'll see it. Okay. All right, let's do some more compare and contrast. Okay, now when you see the addition stuff happen, it should be just screaming to you, do the antiderivative separately. You know, so the antiderivative of a sum is the sum of antiderivatives. I can do those antiderivatives separately. Sine of x is a simple function. Antiderivative of sine is just negative cosine. For 3x, it's 3x squared over 2. So, I mean, this is like the easy schmeezy problem on the list. So here it is, 3x squared over 2 minus cosine x plus c. And I believe that minus is correct. Remember that when you take the derivative of cosine, it's negative sine, so the negative of the negative, the opposite of the opposite, opposite of the negative. All right, so that's it for that one. Love it. Okay, next up. Okay, so immediately I'm looking at this x squared inside of sine, and I'm saying that's a function inside of a function. That's like f of g of x. Okay, and when you do the derivative of sine of x squared, or when you did the derivative of cosine of x squared, there needed to be a 2x in there from the chain rule. Okay, so since this is it's a function inside of a function, now the derivative of x squared is 2x, and so I see that x there. Okay, now again, the 3 is not a big deal. We can make all of that happen separately. Okay, so what are you saying? You know, if it's a function inside of a function and the derivative of the inside is there, this looks like u substitution to me. Okay, all right, so what is u? X squared du dx then is 2x. Dx solving, so I'm multiplying by dx, I'm dividing by 2x, so du over 2x. Okay, so this problem becomes the antiderivative of, I'm going to bring the 3 out, x sine of u, and instead of dx, I'm going to write du over 2x. Now again, this x needs to divide out, and so when I do that, I can bring the 2 out, so this becomes just 3 over 2 times the antiderivative of the sine of u. Okay, so now I can do 3/2. Antiderivative of sine again is negative cosine of u plus c. Okay, so just a quick little note there. I kind of did a couple of things on the fly there. That was the u, and I brought out the 2. I think that was it. Okay. All right. You cannot do the antiderivative factor by factor. In other words, if you have different factors connected, you know, things connected by multiplication, I cannot do 3x squared over 2 times negative cosine. That is just so not it. In the same way, if I go back and try and do the derivative of this, I'd have a whole product rule to follow. Okay, I'm seeing people doing crazy stuff like this where, you know, they're doing the antiderivative of a product by, you know, just taking the antiderivative of terms. Similarly, you know, with division, so like, let me pop back here for a second. I'll go back there in a second. I have people doing 3x squared over 2 over x cubed over 3 minus 3x, and that is just so not it. You can't take the antiderivative of a quotient by doing the quotient of the antiderivatives. You cannot do that, because when you do the derivative, you have this big ugly Hody high minus Heidi ho over ho ho rule that you have to do. It's much more complicated than that. Okay? All right, so as we look at this third example on this slide, notice that the x squared is gone. Okay, so as I look at sine of x, well, the inside, this is not a function inside of a function. This is not an f of g of x kind of thing. This is just the sine of x. And if I do the derivative of x, I don't get x. I get 1. So, okay, is there any other inside of a function kind of thing? I mean, here's a 3x here, but the derivative of that isn't sine. So these two things are seemingly unrelated. Okay, so this is probably a situation where we're going to do antiderivative by parts. Okay, now parts is our latest one, and it's also the most complicated one. And so let me kind of remind you the rule. Okay, so we're supposed to do the antiderivative of u dv equals uv minus the antiderivative of v du. And I always remember voodoo, like voodoo, on the end. And remember that we had a list, a way to kind of remember what we want u to be. In order, you look for one of these. Okay, and again, so a log function, inverse trig, polynomial like a power function, exponential, and then trig. So that's the order that we're going to look for things. And as soon as we find one of those things going down the list, then we'll say, sweet, I'm done, that's u, and then we start doing it. Okay? All right, so here we go. So I have 3x and I have sine of x. Well, do I have a log function? No. Do I have inverse trig? No. Do I have a polynomial? Well, 3x is a monomial, which is a polynomial. So I'm going to go with that. So this is u, and this is v. Now don't just assume because they're in order from left to right that's always the case. That is not always the case. Okay, all right, so we're going to remember what we have to do is we have, if u is 3x, then du dx is 3, so du is 3 dx. Okay, and then v, well, dv is sine of x, dx, sorry. So v then is negative cosine of x, and that's it. We'll do it with the plus c at the end of this whole craziness. Okay. All right. So now we're going to follow the rule. Okay. So u dv. So the integral of u dv is equal to uv. So 3x times negative cosine x. Sorry, I don't have a lot of room here. I probably should just start this down there. All right. Tell you what I'm going to do. I'm going to do some rearranging here so we can follow this a little. All right, that's a little better. We can follow the plan here. All right, so the integral of, okay, I marked this wrong. That's dv, and it includes the dx. Okay, and that really should be red, and I know you're thinking, come on, Mr. Sanford, this is just a little OCD. All right, so here we go. Is uv, so 3x times negative cosine x, okay, minus the integral of v, okay, so that's negative cosine x, du, which is 3 dx. All right, so at this point, I'm going to do a little cleanup, and then we'll finish it up. So negative 3x cosine. I'm going to pull this negative and this 3 out in front of the integral, so this becomes plus 3 cosine x dx. And so all of this, antiderivative of cosine is sine, not negative, plus c. And color me done. All right. Okay, I don't want to keep recapping everything because I know you can rewind, but I'm going to anyway. I'm sorry. I just can't. It's just the teacher in me. Okay. I have a sum of simple things. I can just do antiderivative. I have a function inside of a function with its derivative present. Use substitution. I have a product that does not have a function inside of a function with its derivative present. That's integration by parts. Okay. Okay. Last one. And again, I'm purposely looking for things that look similar. Okay. All right. So this one, I don't see a function inside of a function. Okay. It's just straight up e to the x, and then I have x squared. They just look like random stuff next to each other. I want to contrast that with this. Here is a function inside of a function, and if that's u, then du is about this x, because the du would be 2x dx. Okay, so all of that to say that this one's going to be u substitution. This is a product based on not, this other one's a product based on not a function inside of a function, so this one is probably going to be parts. Now, I should warn you that, you know, things can get much more ugly than what we're seeing here, and so you can have u substitution inside of parts, and it can get nasty, you know, so what can I say? Sorry. All right, so this is u dv minus equals uv minus v du. Okay, so that's the parts rule, and it's lipet is the way to remember the order, how we're choosing u. Okay, I don't see any logs, don't see any inverse trig. Polynomial I see, so this is going to be u. It wins, it's before exponential, so that's the one. Okay, the other one then is dv. And again, unfortunately, they're just in order, and that's just how it worked out. What can I say? All right, so if u is x squared, then du is 2x dx. So what we did was du dx, and I multiplied both sides by dx. Okay. If dv is e to the x dx, then v is the antiderivative of e to the x, which is, excitingly enough, e to the x. Okay. Now, what you may or may not have noticed here, and I'm about to change up what I'm going to do just because I noticed that this is 2x, and when I get down to v du, I'm still going to have e to the x times x, and I'm going to have to do this twice. And I'm going to cheat a little bit. I'm going to do the tabular form, and just because it's a little bit easier. So this is going to be u and the u primes, and then the other side will be dv and the antiderivatives of them. Okay, so on the one side I'm doing the derivatives, on the other side I'm not. And the u is still going to be x squared. So u is x squared, and then I have 2x, and then I'm just going to have 2, and this all went all the way down to a constant, so I'm done. Okay. On the other side, I'm going to have dv is e to the x dx. Antiderivative of that is e to the x, and the antiderivative of that is, you guessed it, e to the x. And, all right, sorry, I'll go one more step on the other side. 0 e to the x. All right, I forgot it didn't go quite far enough. All right, and then, so my first uv is this. Okay, so that antiderivative is all going to be equal to x squared e to the x. Okay, so that initial antiderivative is going to be equal to x squared e to the x. Remember, the signs alternate. So this is going to be minus 2x e to the x. Alternating signs, plus 2 e to the x, and then we're done, well, except for plus c. Okay, so that's by parts in the tabular method. Tabular just, again, means table. Okay, all right, so that was actually pretty straightforward. Okay, this other one, again, if this is a function inside of a function, u equals x squared du dx is 2x, so dx will be equal to du over 2x. All right, so following the pattern here that we're seeing here, I have antiderivative of x e to the u times dx, which we're going to replace with that. Okay, and I'm loving that those x's divide out. Of course, that's by design. So I have really pulling that 2 out, 1/2 e to the u du, also known as 1/2 e to the u plus c, which we will substitute that u back in, 1/2 e to the x squared. And that's that. Obviously, very, very different problems. And so at this point, I guess I would just be thinking in terms of like a checklist kind of thing. You know, can I do the antiderivative? Can I rearrange this with algebra so that I can just do the antiderivative? Now, if you see a product or a quotient that you can't separate into separate things that simplify down to something that you can do an antiderivative of, then you need to be thinking either u substitution or parts. And if that happens, then, you know, it's a little more work, and that's just part of it. Sorry about that, you know. Okay, so just don't, you know, go off on the deep end and just start doing your own thing. So, all right, well, that's enough for this one. And thanks for watching. SanfordFlipMath. Bye.